Hi class, welcome to topic 5 DQ1. In this DQ we are going to start working on statistics. We're going to pretend that we have three sets of data. So we took some wells and we measured the E. coli in the data. We measured it before we did anything to the wells. Then we did a treatment to the wells. The treatment is supposed to lower the amount of E. coli in the wells. So then we measured the amount of E. coli in the wells after the treatment. And then we're going to also look at the improvement amount. We're hoping to see the E. coli lower. If the treatment's working, we want to lower the amount of E. coli. And we'll look at the improvement to see if we've lowered it, and we'll do the after minus before to find that improvement. So in this DQ, we're going to look at finding the min, max, the median, standard deviation, the range. We'll look at percentiles, and we'll look at the empirical rule. So let's get started. So go over to the improvement tab. As always, start by entering your name, and then you should be given data in columns D and E that represent the before and the after data. So the before data is the amount of E. coli in the well before the treatment. The after data is the amount of the E. coli in the well after treatment. In column F, we're going to find the improvement data. That is going to be the after minus before. So we want to take the amount of E. coli after minus the amount of E. coli before, do an Excel formula with cell references, and follow this all the way down column F. You can autofill that formula down column F. Just make sure you keep doing after minus before, column E minus column D, and then this will give you your improvement data. So we'll be looking at the before, after, and the improvement data. So for the improvement data, since we are doing after minus before, those negative values show us the E. coli is decreasing, and that's what we want to see. If we had positive values, the E. coli is increasing. That's not what we want to see. We want to see the E. coli decrease. Okay, so we've got our data. Let's find some statistics about it. So we're going to move on to part 2. In part 2, we're going to find the mean, median, standard deviation, and range for the before, after, and improvement data. So we'll do each function for each individual column. You can autofill these to the right as you go. I'm going to do the functions for the before data, and then I'll leave the after and improvement for you guys to do. So to find the mean, you want to use the average function. So you'll type your equal sign, type out the word average, open the parenthesis, and then go highlight the data in the appropriate column. So I'm working in the before data, so I'll go over to column D, which contains all of my before treatment numbers, and I'll highlight all of those numbers. After I finish highlighting, close the parenthesis and hit enter. Close the parenthesis and then hit enter. Your numbers should turn green as you go. We want to format everything as number with 2 decimal places. So as I go, I want to adjust this so it has number with 2 decimal places. So then again, I did equal sign, average, open the parentheses, highlighted all the numbers in column D because I'm looking at the before data, close the parentheses and hit enter. So you'd follow the same process for the after and improvement. Just make sure you highlight the new column of data. Use the after column for the after, use the improvement column for the improvement. For median, you're going to use the function median. So equal sign, type out the word median, open the parenthesis, and go select the appropriate data. So for the before data where I'm working, I'm going to go to column D and highlight all of the before numbers. Once I finish highlighting, I'm going to close the parenthesis and then hit enter. And just like before, you can autofill this to the right. You can autofill all of these functions as you go. So there's my median function. I've highlighted everything in column D, and then I hit enter. Standard deviation, we're going to use the stdev.p. You have a couple of options for standard deviation. The .p is for a population, .s is for a sample. We're going to go ahead and assume we have the entire population, so we're going to use the P one. We're going to open the parentheses, and then again highlight the appropriate data, close the parentheses, and hit enter. Ooh, I went too far. There is my standard deviation function. stdev.p, open parentheses, highlight everything in column D, close the parentheses, and hit enter. All right, and then the last one for the range. The range is found by taking the maximum number minus the minimum. So you need to find the maximum minus the minimum. When we do this, we have max and min functions, so we can make Excel find the max and min for us, and then we can focus on the subtraction. For the max and min functions, we need to highlight all the data like we've been doing, and we're going to highlight it for both functions. So for the range, I would start with my equal sign, start with the max, type out the word max, open the parenthesis, and go highlight that column D, all of the before data. And when you're doing this, all of your ranges should look like D4 to D120. After I finish highlighting for the max, I'm going to close the parentheses, and I'm not going to hit enter yet. So we have to subtract off the min. So close the parenthesis on the max, then do minus, min, open the parenthesis, highlight the same data. So both ranges in your functions should both be D4 to D120. Once you finish the min function, you can close the parentheses and hit enter. All of these numbers should be formatted as number with 2 decimal places, and you can autofill all this over to the right for the after and the improvement data. You don't have to do each one individually. You can grab this and you can do your autofill. Okay, so go ahead and finish the rest of the table, and then we'll move on to the percentiles. So for part 3, we are going to find 2 different percentiles. We're going to find the 16th percentile and the 84th percentile. So the percentile is a number. It's a number in our list of data that represents where that percentile is, where that cutoff is. So the 16th percentile, the number we get for that represents where 16% of our data would fall. So once you get that number, anything lower than that represents 16% of our data. The 84th percentile, whatever number you get for the 84th percentile, that number and lower than it represents 84% of the data. All right, so let's do the percentiles. When you do the percentile, you're going to type the equal sign, type out the word percentile. Again, we're going to have a lot of options of different percentiles you can use. We're going to go ahead and just use the percentile one. The first 2 are also acceptable. The one that ends in EXC and the one that ends in INC. There's a couple different ways to do percentiles. Like you've seen on the homework, there are 2 different options. Just like Excel, you have those couple of options because there's different ways, different methods to find percentiles. They should all get you close to the same number. In Excel, we're looking for those to turn green. Okay, so type your equal sign, type out that percentile, open the parenthesis. We are looking at the improvement data only at this point. So we're done with the before, we're done with the after, we're focusing only on the improvement data. So I'm going to go up to column F, and I'm going to highlight all the numbers I have in column F. After I highlight everything in column F, your computer may auto-fix it to say improvement, and that is perfectly fine. It may also say F4 to F120, and that's perfectly fine as well. So after you highlight the numbers in column F, type a comma, and type the percentile as a decimal. The first percentile is the 16th percentile, so 16th as a decimal would be 0.16. Think of it like 16% as a decimal, 0.16. And then that gets you the 16th percentile. Try the same idea with the 84th percentile. Use 0.84 to represent the 84th percentile. All right, now that we've calculated the percentiles, let's move on to part 4A. We're going to start looking at the empirical rule. So the empirical rule divides our data into 3 different sections. We have 68% of the data, 95% of the data, and 99.7%. So this is a picture that shows the empirical rule. It shows how it chunks out your data. So when you look at your standard normal distribution, you should have a majority of your data centered in the middle, centered around the mean. And then as you move away from that data, you're going to have less and less of it because you're moving farther away from the mean. So the empirical rule chunks this by how many standard deviations you are away from the mean. In our DQ and on our major assignment, we're looking at 68%. We want to find 68% of the improvement data. So we're looking at this middle section here, that very middle 68% of the data. 68% of the data is in between plus or minus 1 standard deviation of the mean. So what that means is that to find the bounds for 68% of the data, the lower bound is going to be found by taking the mean minus the standard deviation, and then the upper bound is found by taking the mean plus the standard deviation. And we want to use the mean and standard deviation from the improvement data, improvement statistics that we found in this column K. Okay, so for the upper bound, I want to add, we're starting with the lower bound. For the lower bound, we want to subtract. So equal sign, find the mean for the improvement, and then we want to subtract the standard deviation. And I want to use the standard deviation for the improvement. So I'm doing K9 minus K11. And then for the upper bound, I'm going to do the same thing, but I'm going to add. So I do my equal sign, the mean, plus the standard deviation. And that is for 68% of the data. So if you had 95% instead of 68%, you would do 2 standard deviations. So your formula would include a 2 in it, 2 times the standard deviation. So here you would put it 2. That is if you had 95% of the data. And then if you had 99.7, you'd include a 3. So that's what the empirical rule. It helps you determine which formula to use, how many standard deviations you are away from the mean based on that percentage. We're using 68% in our DQ, so keep it just with the plus and minus. K9 minus K11 for the lower bound, K9 plus K11 for the upper bound. Okay, so what these bounds are telling us, that negative 15.44 and that negative 4.80 that I got, that is telling me that 68% of my data should be centered in between those 2 improvement values. So I could say that I expect 68% of the wells to see an improvement between negative 15.44, negative 4.48. They should have the E. coli reducing by 15.44 to 4.8 E. coli. That's what we're talking about. So when you move to part 4B, you are trying to phrase all of that into a sentence. There is a sentence structure here that helps you work through the sentence. So you want to say about number wells, so there's a reduction between the lower bound and upper bound. The number should not be a percentage. It should represent the number of wells that are 68% of the total number of wells. Okay, so let's find that number. So we have, how many total wells do we have? We have 117 total wells. So I need to figure out what is 68% of 117. So let me go back up to my answer box. I'm going to do this off to the side. So I'm going to say, what is 68% of 117? How many wells are 68% of 117? So that gives me 79.56. 79.56. So what you could say is you could say about 79.56, about 79 wells show a reduction between 15.44 and 4.80. And mine is a reduction because my values were negative. So if yours is positive, if you're seeing positive numbers for your lower and upper bound, then the E. coli is not reducing, it's increasing. So you'd say you see an increase between the 2 values you got. Mine are negative, so that's why I'm saying a reduction. I'm decreasing, I have a reduction in mine. Okay, so part 5. What, if anything, do your calculations in part 4 tell you about the effectiveness of the treatment on the wells? So here's where you need to talk about whether you got positives, negatives, and whether or not the treatment is actually working. So for my DQ, for my numbers that I got, all of my numbers are negative in the improvement data. My lower bound, my upper bound are negative, my percentiles were negative, and in my improvement data, I got a negative mean, a negative median. If you look at column F, all of these values are negative or they're 0. So what that is telling me, it's telling me that the treatment is working. It's not working for every single well, every single well, because I do have values that are 0. So some wells didn't change, but in a majority of my wells, I can say the treatment is effective. And I can actually confidently say that in 68% of my wells, in that 79 wells, I can say that you expect to see a reduction of 15.44 to 4.8 E. coli per milliliter. So that's what you want to talk about in part 5. So is it working? Are you actually seeing a reduction in the E. coli, or are your numbers increasing? If your numbers are increasing, it's not working. The treatment's not working on the wells. And then talk about what you see, and then talk about what you could expect if this treatment were to get projected to a larger set of wells. All right, I hope this helps. Let me know if you have any questions.